Hello, and welcome back to another exciting episode of Hacked and Unfiltered. Today's topic, we're going to talk about inside the supply chain in more detail. In the last episode, we talked about cloud identity warfare, a very dear topic to my heart. We broke down how attackers do not always need ransomware, malware, and some dramatic exploit to create a real damage. Sometimes the only need is one compromise account, and we talked about this in more detail in the last episode if you have not seen it. At the end of the day, it's going to come down to at least one stolen token, right? Or one approved application, or one trusted session. And the big takeaway from our episode 2 was that modern environment attackers often win by abusing the trust. Today, we're taking this idea one step further. Because what happened when the things being trusted in is not a person, but a software? What happens when a package, a vendor, a build tool, or an update becomes the path into your business? That is what this episode is about. Today, we're going to talk about supply chain compromise, how trusted software becomes the attack path, and how attackers use dependencies, pipeline, vendor, and even automation to move through organization without always attacking them directly. And most important, what should you do about it right now? So sit back, relax, get your coffee, because this is going to be a great episode, another one. So let's talk about what supply chain compromise really means. That is a big question on many people's mind, right? So let's start this simply. First, understanding that the supply chain compromise happens when an attacker targets something you already trust in order to get to you. Now, you might wonder, that trust thing might be a software package, or it could be a plugin. It could be a script which you and your team has built, or you have acquired it from a trusted site. It could be a specific GitHub action, right? Or think of a image in a container, or some kind of cloud integration, or some kind of remote access. I can talk about this from a list perspective. It's a very long list, right? It can be from anything from a SaaS connector perspective. It could be a code library. It could be a software update. It could be a security tool. Like, I don't know. There are many ways these attackers can come in and compromise the supply chain, right? The reason this matter is because attackers do not always need to force their way in through the front door. Sometimes they let your trusted tools carry them in. If you have not followed episode 1 and 2, we talked about this in very detailed way, right? Now, some of the things, I'm going to give an example, okay? So it will be easier for you to understand. So here's a simple example. You have to imagine your deployment team uses some kind of package for handling, let's say, PDF uploads, right? Now, if it's a PDF upload, it is very popular. It works well. Nobody on the team thinks twice about it, right? Even my organization, when I have to download something in my laptop, I have to get an approval. I have to give some kind of explanation to my security team that I am downloading something on my laptop, right? So imagine there are certain applications we trust blindfolded, right? And the code still compiles. The app still works, and the deployment still succeeded in most cases when you have that deployed. But buried inside that update is a code that quietly reads the environment variables and sends a secret out to an attacker control server. Nothing dramatic happens on the surface. No blinking red lights, no sirens, no ransomware notes, just software doing untrusted things. And that is what makes supply chain compromise so dangerous. And this is why this is one of the biggest trust problem in the cybersecurity, that modern organization run on trust. And you would agree with me. If you work for an organization and you run an organization, you need to have a trust in order for you to run certain applications, certain programs in your system. Now, all these organizations have some kind of developers, my apologies, developers who trust the open source packages, right? They have security team trust scanners, like most of the companies do have today. And if you have not, please do so. Operation team do trust some vendors. They have a trust factor. They have a checklist they have to follow. And even the cloud team trust automation, right? They are looking for some kind of automation to put in play. And even for business perspective, business team do trust integrations. When it comes to leadership team, they do trust the software stack to keep the business moving, but this is not the trust exist issue. The issue is that the trust expands faster than the validation. A lot of organizations cannot clearly answer what tools have access to production, which dependencies are more critical, which vendors still have active sessions or active access. I can talk about it for many other questions, but organizations do need to ask this question. Like, what service accounts are tied to automation? Yes, everybody wants automation. Cloud team wants automation. But we need to ask that question. Which integrations can read sensitive data? Which secret lives inside the build system? Like which old plugins are still quietly running? So I'm going to give a business example. So for those who are listening to this and trying to getting some picture out there, that think about a company that using a support platform, right? That connects with a CRM system, let's say with Salesforce and others, some kind of email system with M365, or some kind of ticketing system like a ServiceNow or something like that, right? At first, it only handled customer support. Then it got connected to more tools for convenience. Now it can read customer data. It can definitely trigger a internal workflow. It can send outbound emails. It can also create tickets. It can pull notes and history. And not to think about, it can touch multiple business systems. If that platform for 1 second, think about, get compromised or its token gets abused, the attacker may suddenly have visibility and influence across multiple departments. Not because the company was hit directly first, but because the trust had already been extended too far. And that is a real lesson here. Supply chain risk is about inherited trust. Now let's talk about one of the biggest pieces of this conversation, CI and CD, continuous integration and continuous deployment. Now, I have to give you an example because CI/CD is critical infrastructure for modern software businesses, right? And the example is, let's say company uses some kind of GitHub action, right? Every time code is merged into the main, the workflow runs like this. It runs a test. It builds a container. It scans the image. It also pushes the artifacts to the registry. Then it goes into deploying to staging area. and then in some cases push it to production. Now think about the workflow likely has access to, let's say, cloud credentials or some kind of registry token, some kind of secret to test and deploy. It can have possibly access towards packages, publishing key, or infrastructure roles, or repository access, right? That is a lot of trust concentrated in one system. Now imagine one GitHub action inside the pipeline get compromised. Not your cloud account, not your source code, just one action. The next time the workflow runs, the malicious action quietly collects environmental variables, all the cloud keys, all the registry secrets, and even the repository metadata. The build still succeed, test is still passed, deployment is still complete. From the team perspective, everything looks normal. But now the attacker has what they need to move forward. They may access your registry, review private repositories, they may map your cloud environment, they tamper with your future builds, or wait quietly until the right moment. This is what unethical people do. I call them knuckleheads. That is why pipeline security matters so much. The software factory itself can become the attack path, and we need to take it very seriously, guys. Now let's talk about open source, because a lot of people want to understand open source as well, especially with open source power. It powers a huge part of modern software role today. The problem is not open source itself. The problem is blind trust. We talked about trust many times already now. A lot of teams use open source packages, all these NPM packages and stuff like that, because they save time and solve problems. That makes sense. But popularity is not the same as safety. So let me give an example again. Let's say you're building a software, or you're a developer, and wants to install a package called Payment Helper Tool. They accidentally type Payment Helper Tool instead of S in it. It's a tiny typo, install a malicious package, upload by an attacker. The code still runs, app still builds, but now the attacker has the code execution in the development and a build environment. Let it sink in. Let me give another example for those who want to expand this out. Let's say your company has an internal package called Corp Auth Library. Your build process is not tightly configured. An attacker publishes a package, a public package with a similar name, Corp Auth Library. But your system mistakenly pulls the public version first. And that is dependency confusion problem. Again, the build may not fail, everything looks fine, but your trust chain has already been poisoned. And this is why open source governance matter. It is not enough to know what your team intentionally installed. You also need to know what got pulled in behind the scenes. Vendor compromises, remote access risk. It's a lot of things. So let's move beyond the software packages. Supply chain risk also include vendors, as we talked about. So it can be any type of vendor, right? It doesn't matter which vendor that is. But imagine a manufacturing company. I deal with them a lot. Uses a third-party vendor to support its equipment monitoring software. To save time, the vendor has some kind of persistent remote access. Everyone is used to it. No one revisits it. Now imagine the vendor gets compromised. An attacker steals the vendor credential or abuses the vendor remote management tool. They do not need to attack the manufacturer directly. They enter through the trusted relationship. From there, they may access the support system, they may access the map of the entire internal network, they move towards engineering workstation, they can identify high value assets, they can use trust to avoid trigger detection. There's so many things. This is exactly why vendor access must be treated as a part of your environment. If a vendor can touch your system, then a relationship is part of your attack surface. I have to give you a lot of examples here. This is a very sensitive topic. Let's say a company connects a marketing analytical platform to your website. It has some kind of CRM, it has email automation. The platform can view all the customer actions. They can read context record, they can trigger campaign workflows. If the platform is over permissioned and get abused, the attacker may be able to manipulate the customer messaging and extract valuable business information. Again, the issue is the same. A trust connection between an operational risk. Security tool can become a part of a problem too. And this is one of the hardest truth for security team. Security tools can also become supply chain risk. We trust scanners, we trust monitoring tools, we trust EDR platform, we trust vulnerability management system, we trust backup tools. Attacker knows this. Imagine a security scanning tool is built directly into your CI pipeline. It has access to source code. It runs automatically on every build. The team trusts it because it is security tool. Now imagine that tool is one of its update channel gets compromised. The trusted scanner may also be used to read source code, all these collective secrets. It can execute unwanted logic in highly privileged workflow. I'm not here to scare you guys. I'm here to tell you the truth, what I'm seeing. That creates a uncomfortable truth, which we all have to understand. A tool being security related does not make it safe by default, guys. Wouldn't you agree with that? Because security team built it or they approved it, it's safe already. No. It actually makes it more important to review closely because of how much trust it often receives. Now, I will also give another thing, which is from a team perspective. Team gets this wrong all the time. Let's be direct about some mistakes, okay? A lot of team gets a supply chain security wrong in more predictable ways. They trust popular tools too much. I'm a victim of that as well, believe me. But I stopped trusting all the applications specifically. They also trust, or they can assume, automation is neutral. They give pipeline too much access. They leave all the secret exposed in a build workflow. Sometimes. They also forget to review vendor access. They do not have, do not know how to shut off or shut down a compromised trust fast. Let me give a practical example. So imagine a company notices some kind of suspicious activity tied to a deployment process. But now everyone is scrambling because nobody knows who owns the pipeline, what secret it lies, how to pause the deployment safely, what system it depends on, how to revoke a connected vendor or some kind of integration. That delay is where the damage grows because the team is not just responding to an attacker, they're responding to their own lack of visibility. Let's walk through a realistic scenario from start to finish. Okay. Imagine a cloud first company. It uses what? GitHub for code. It uses some kind of public package repository, GitHub Actions for build, a cloud registry for artifacts, possibly AWS for production or Azure for production or GCP for production. I don't know what they use, but imagine AWS for production. Third-party monitoring tools, and possibly Slack and emails for alert. Now, the company stores several secrets inside the build environment. A developer merges routine code into the main branch. The workflow starts with a compromise third flow action, runs as a part of a build process. It quietly runs cloud keys. It quietly runs registry credentials, repository metadata, even deployment variables. The attacker now has options. They can inspect private repositories, access artifacts, registries. They can go into mapping cloud resources. They can go into production services and identify everything. They can tamper with future builds if you need to. And also, they can stay persistent for later use. Meanwhile, the security team may not see everything, obviously, because the build completes successfully. I'm a victim of this, guys. When I first dipped my toes into it, I was trusting too much. When the build completes successfully, the application still works, the log looks routine, no endpoint malware was fired, the attacker used a valid automation path. And days later, company sees some kind of unusual cloud behavior or strange registry activity. Now, incident response begin. The IR begins. But the actual intrusion did not start in production. It started inside the trusted automation. That is what you need to understand. The supply chain compromise often begins quietly and hide inside a normal looking trust. So, what your organization needs to do and need to know, and what should you do, especially now. So, let's get it practical. If you're listening to this, asking what your team should do next starts here. First, inventory the trust chain. You need to know every pipeline with production access. You need to know every third-party integrations with broad permissions, every vendor with persistent connectivity, every major dependency tied to critical systems, and every system which is service account tied to automation. And if I were to be you, I will also cover every place where build secret lies. Second, reduce trust by default. Do not let every tool touch everything. Do not let every integration have broad scope. Do not leave standing access where temporary access would work. And most importantly, protect your CI/CD like privileged infrastructure. Now, you might say what that means. You have to think about strong access controls. You have to think about some kind of protected branches. You have to control runners. You have to have a tighter secret handling. You need to have a better monitoring, better backups, restricted deployment rights, and artifact integrity checks. Review all the open source dependency continuously, not once, continuously. Look at direct dependencies, abandoned packages, I don't know, unexpected updates and naming confusion risks. Operationalize vendor risk. Do not stop at paperwork. Know what your vendor can touch today and how quickly you can disable that access. Build your emergency isolation process. Ask your team, can we pause deployment fast if something goes wrong? Can we revoke pipeline tokens? Can we disable compromise integration immediately? Can we stop artifact promotion when trust is in question? Or even can we rotate exposed secret quickly? Rehearse the incident. You need to internally run a tabletop exercise to identify malicious dependency injections. You need to run tabletop exercises for understanding compromised build tooling, poison images, vendor remote access abuse. I can tell you a list. Some of them also include suspicious package behavior and pipeline compromise. Because if your team has never practiced this, the first real incident can be slower and harder than it needs to be. Now, I know you're going to be wondering that how I'm going to go take this information and going to explain that to my non-technical people, right? So here's the simplest example, the way I explain to supply chain risk to non-technical individuals. Attackers do not always attack a company directly. Sometimes they attack the software tools, vendors, and service companies that already been trusted. Once the trust being compromised, it can carry the attacker into the business without triggering the type of alarm people expect. And that is why supply chain risk matters so much. It is not just about software bugs. It is about weaponized trust. What it means for leaders like you. If you are a leader listening to this, the topic belongs to you on your. It must be on your radar. Supply chain compromise is not just about deployer problems like all these deployers who are deploying certain things, certain packages, or developing all the platforms for you. This topic belongs on your radar. It is not just a security team problem. It is a business risk problem because it can affect your software integrity. It can trust your customer trust. It can expose your cloud exposure. It can operationalize your uptime. It can deal with a compliance issue. It can create vendor dependencies. It can have an instant recovery or brand reputation. If your organization cannot clearly explain what tools it trusts, what those tools can access, and what happened if one of them get compromised, then your business is carrying more risk than it probably realizes. And that is the real issue. So let's bring it home, guys. If there's one message I want to give you to take away from this today is attackers do not always need to break your system directly. Sometimes they only need to compromise the things you already trust. A package, a plugin, a pipeline, a scanner, a vendor, an update, a connection. That is what supply chain compromise is so dangerous. It turns everyday trust into attack paths. So what should you do after this episode? Start with one action this week. Pick one. Whether you start with inventory every pipeline with production access, whether you review all the third-party integration with broad permissions, identify the most critical dependency in your stack, or confirm where your build secrets are stored and who can access them. Review which vendor still have active connection to your critical systems, or even go one step ahead or pick one like test whether your team can pause deployment quickly during a trust incident. One action is enough to begin, because action is what turns awareness into defense. I hope you liked this episode. In our episode 4, we are shifting from trust software into real world operations. So we're going to talk about OT under pressure. We'll break down why operational technology, industrial control system, segmentation, vendor access, and engineering workstation matters so much in today's threat landscape. We'll also talk about what makes OT different from traditional IT, and why attackers are on those systems can create real world disruption. Before the next episode, ask your team this question: if one trusted tool, vendor, or software component in your environment was compromised tonight, how far could that trust spread before we saw it and stop it? If that answer is unclear, that is where your next security conversation needs to start. Thank you for joining Hacked and Unfiltered podcast. I appreciate you listening and getting some things out of it. If you like this episode, please share that with the people who can take benefit and take advantage of this. Follow me on Substack, LinkedIn, and other platforms. And if you have any questions, always reach out. See you in the next episode, episode 4. Thank you, everyone.